For Grasshopper, it's understand that there is this curve, that is, there is a starting point for the curve and there is an end point for the curve. If you remember from like a previous example, we just used a point on the curve without actually going into the depth of this, that how that works. But for Grasshopper, it understands it as a point 0, attribute 0, and attribute 1 for a starting point and end point of any curve. Now, one of the things that basically we have to do every time that we want to work with any curve to find a specific point or just breaking down into different pieces is that we have to make sure that we are reparameterizing the curvature. And whatever range that exists, it just change that into the value of 0 to 1. So if I go back here to my Grasshopper here, I can use the points on curve, right? And if you think about that, points on curve, you remember there was this specific value that it has here, and you see that that is the center point of that curvature. Now, if I zoom in here, you see that if I change it, it goes all the way to 1, which is at the end point of the curvature. And if I bring it all the way down, it's going to go back to 0, which is the starting point of the curvature. When I draw this curvature, I started from that specific point. Now, I can flip the order of the curve itself, meaning that if I go back here, and if I right-click here, and if I basically, let's see here, flip curve, if I get the flip and then put it back into the input of find a point, you see that now the curve itself is flipped, and that is going to be starting point of my curve. There are a lot of applications for this flip the curve. Sometimes you are generating some of the curvature coming out of different like a geometry, and you try to find like a divide them, finding the points on it. And if you remember, the order of the points is important in terms of how the Grasshopper evaluate and do the mathematical function or connecting them. So flipping become a very helpful tool in order to do that. Now, in first example, we kind of go through the divide factor, which we use the one curvature and we just divide it. So let's go back to my Grasshopper again, and then I'm going to go for a divide curve. So if you recall from the first time, that divide is basically going through the curve and then breaking down into like a same length distance for each of these curvature. But we also have option for the curve. If I go back here, in order to do the different type of like a divide as well. So if I go to the analyze here, I have the one second, let me find the second one that I was looking for. Not here. Oh, the division. Yeah. On the division, you see that I can use, for example, a contour to divide. I can divide it based on the distance as well. Like, for example, if I go and use the distance this time, if I have my curvature here, and the distance is going to be, let's say, for example, right now is the value of 0. And if I go here and then type, for example, 3, and put it in this input, you see that this time it's just divide my curvature based on the distance of 3. And if I just turn this point off for a second, you see that it just use the distance from the base point of my curvature, and it's just go all the way down 3, 3, 3. It's just assuming that it's drawing a radius from that specific point, meaning that the segment that I have is not a same length throughout this. So that's another thing to just have in mind. Again, when does this happen is like, for example, you might want to create something based on one specific attractor, and you try to divide the curve based on that. That would be another like an option to work with. So